domain and the range. First of all, let's just start with some of the properties of log. Alright, so log base b of x, y equals log b base b of x plus log base b of y. Now for the other one, it's just same thing with only division is going to be subtraction instead of addition. See? It's pretty easy. Now for this one is when the log has an exponent, for example, log base b of x to the power of, let's say, a. You can actually take this a and just move it to the front of log, so it'll equal a log b of base b of x. Now an example of that, let's say, would be log base 3 of 10 to the 5th power. That would equal 5 times log base 3 of 10. Now let's say you have something like 21 log 5, this base 5 of 6 to the 1/3 power. You can actually take this 1/3 and multiply to this and actually get 7 log base 5 of 6, and you can just get rid of that exponent. Actually, it's kind of useful, and you use that quite a lot in some of the log stuff. It also works, let's say you have log base 5 of 1 over 100. Well, we all know 1 over 100 is the same thing as 10 to the negative 2, so you can just rewrite this as log base 5 of 10 to the negative 2, and just move the negative 2 right there, and just get negative 2 log base 5 of 10. It's pretty easy. Now the other property log is the change of base. This is what you use to find the solution to something if your calculator can't put the base, which most of them can't. Let's say just log b of x. Change of base would just make it log base a of x over log base a of b, and a equals any number. But generally, if you're plugging into a calculator, you want to use 10 as a. Then you can just plot in your calculator log x over log b, and obviously x and b are going to be numbers. I'm just using variables because it's kind of easier to understand that way. Now let's say you have something like b log base b of x. It actually just crosses out and you just get x. So this equals x. Just keep that in mind. Alright, now let's actually find out how we would find an inverse of a function. So let's say we're given f of x equals, whoa, my tablet just glitched out there. Alright, let's say we're given that 2x minus 3, oh whoa, hold on. Alright, so let's say we're giving f of x equals 2x minus 3 over x plus 2. And we need to find the inverse. And then we'll find the domain and range of the inverse and this function. Alright, first of all, let's start by saying the domain of this function. Since the bottom is it's a fraction, and we all know the bottom fraction can't be 0 because you can't divide by 0. So x plus 2 has to be greater than 0. Well, it basically actually doesn't have to be greater than 0, so my bad. X plus 2 cannot equal 0. So x cannot equal 2. That's the domain for this function. Alright, Sorry for those technical difficulties. Also, it turns out I copied f of x wrong. It was actually supposed to be 2x plus 3. That still wouldn't change the domain, but it would drastically change the inverse. Alright, now moving on. The way you would find the inverse of this function is the same way you would find the inverse of any function. Just swap the x's and the y's. Oh, by the way, f of x is the same thing as y. So, to change, it'll just be x equals 2y plus 3 over y plus 2. Now just multiply it by y plus 2 on both sides. Alright, now what I do is I just group the y's on the left side and just move the x to the right. So you get x, y, minus 2y equals, you get 2x plus 3. Now we just factor out the y. And just divide by the x minus 2 to get y on one side. Alright, and basically that's the inverse. Now usually you're going to have to check that, and the way you would check it is, let's just label this g of x to kind of make this a little easier. Let's say this is g of x. So the way you would check is you would do f of g of x and g of f of x, and both of these would have to equal 0. If they both equal 0, then that means this is actually the inverse of this. Basically, g of x will be the inverse of f of x. So yeah. Now we just plot them. So let's actually just do one of them. Let's start with f of g of x. So it's going to be f of negative 2x plus 3 over x minus 2. So 2 Alright, so usually I would just multiply everything by x minus 2 to kind of make it easier to solve. So we get this. Basically just gets rid of this, and so we just only have one fraction to deal with now. And just using distributive property, open all these up and add them together. Alright, now I'm just going to continue. And this does equal x. Alright, so we're halfway there. Now we're just going to have to do g of f of x. And just basically solve this. It's going to be the same way, and you're just going to multiply everything by x plus 2. In the end, you should get this to be also equal x. I've done I did this a little ahead of time, and yeah, you get x for both. So now that you know that, so now we have our f of x and our g of x, and now that we know that our g of x is an inverse of f of x, we can find a domain and range for both. So for f of x, we know the domain is x is such that x does not equal to. So x is basically the domain can be every number except for -2, because that's the number which makes this function defined. Basically, for this one, it's going to be almost the same thing, but instead it's going to be 2 for this one. X is such that x cannot equal 2. Alright, and for the range, you just look at the inverse, and they're opposites. This one's domain is this one's range, and so the range for this one would just be x is such that x does not equal -2, and for this one it would be x is such that x does not equal 2. So that's basically how you would find the inverse of a function and their domains all.